Welcome to the flight deck of the Bombardier Q400. We are jumping right into today's explainer, and honestly, I am so thrilled to have you here. Today, we're bringing a seriously impressive, highly technical piece of equipment to life, the Honeywell Primus 660 Weather Radar System. We're going to walk through a perfectly sequenced pre-flight and in-flight checklist that'll basically transform this complex avionics panel into second nature for you. Let's just dive right in. Here is exactly what we're covering today. First, powering the Q400 radar. 2, advanced weather tactics. 3, stabilizing and scanning. 4, tuning that gain and tilt. And 5, decoding the MFD display.
You know, the physical ergonomics of this panel are actually fascinating. To really lock this into your muscle memory, visualize how your hands are going to move. We're going to start right at that main rotary dial in the lower middle. Then, our hands will naturally sweep across that top row of 4 square push buttons. And finally, we'll move down to the 2 tuning knobs on the left and right. Using this tactile, perfectly sequenced approach, it literally makes learning the whole system incredibly efficient.
Okay, Section 1, powering the Q400 radar. Let's look at the initial power sequence.
So there are 5 main positions on this primary rotary dial. And to instantly lock this sequence into your brain, just use this simple mnemonic: only smart weather geeks test. Ready? O is for off. Power is completely removed and the antenna is stowed tilted up. S is for standby. The electronics are powered up, but we aren't transmitting anything yet. W is for weather. Now the system is fully operational and detecting precipitation. G is for ground map, where the parameters completely shift to enhance those ground target returns. And T is for test, which engages the self-tests and throws a multicolored arc right onto your display. So remember, only smart weather geeks test.
But wait, here is an absolutely critical detail. When you first apply power, like typically when you move the dial to standby or test on power up, the system enters an initial RTA, or receiver, transmitter, antenna, warm-up phase. Basically, the magnetron just needs a little time to wake up. During this phase, you'll get a white wait message popping up in the upper left corner of the MFD for about 40 to 100 seconds. No transmissions can happen until this warm-up is completely finished. If you try to jump the gun and select weather or ground map too early, the system is just going to keep flashing that white wait legend at you.
Moving right along to Section 2, Advanced Weather Tactics. We're focusing on the RCT and TGT modes.
First up on that top row is RCT, which stands for Rain Echo Attenuation Compensation Technique. It's a mouthful, but when you push this, it enables some brilliant circuitry that compensates for your radar signal getting weaker as it tries to punch through heavy rain. It actually measures the magnitude of return signals so you can see the true depth of a storm. And this brings us to our first advanced tip, the cyan caution trick. In RCT mode, the system creates this cyan, or light blue, field. That cyan field is telling you, hey, further compensation here is impossible. If the target is inside that cyan field, the radar literally cannot calibrate it. It is a hidden danger. Because of that, any targets in that cyan area are automatically upgraded and displayed as magenta, the absolute highest threat level.
Right next door to RCT is TGT, or Target Alert. Hitting this button tells the radar to actively monitor for hazardous targets straight ahead of you, specifically targets that are beyond your selected display range and within 7.5 degrees on either side of your heading. If it spots severe weather lurking out there in the dark, a flashing magenta TGT box will pop up, basically yelling at you to increase your display range so you can see the threat. Now, to remember exactly how this works, use the target alert rule of 80. Just remember, 80 or under, watch for the thunder. Why? Because that TGT warning is only going to trigger if your display range is set to 80 nautical miles or less and it's picking up intense, red-level precipitation just beyond that 80-mile mark.
Let's hit Section 3, Stabilizing and Scanning. Time to talk about the STAB and SECT buttons.
The STAB button is pretty straightforward. It simply turns your pitch and roll stabilization on or off. But there is a massive ground operations secret you need to know here, the 4x3 trick. See, when the Q400 is on the ground, the radar automatically drops into forced standby, or FSBY. This is a safety feature to stop it from blasting radiation at the ground crew. But what if maintenance, or you, actually needs to operate the radar while parked on the tarmac? You use the 4x3 trick. Pushing that STAB button exactly 4 times within 3 seconds completely overrides the forced standby mode, letting you operate it on the ground.
Right next to STAB is SECT, the sector scan button. This alternate action switch flips the radar between 2 very different sweeping modes. Your normal scan gives you 12 looks every minute across a nice wide 120-degree sweep, but pushing SECT activates a much faster update mode.
To lock this in, use this math trick. Half the angle, double the speed. Your sweep angle literally cuts in half to a narrow 60 degrees, but your update speed doubles to 24 looks per minute. It's perfect for getting a rapid-fire, focused view of a specific storm cell right in front of you.
All right, on to Section 4, Tuning Gain and Tilt. Let's get our hands on those lower rotary controls. Let's start with the gain knob on the left. This guy adjusts your receiver's sensitivity, and it actually has 3 distinct physical actions: turn, pull, and push. Turning it clockwise dials up the sensitivity. Pulling the knob straight out activates manual variable gain, and you'll get a little gain man message letting you know you're in control. Pushing the knob back in locks the system into its preset calibrated gain, which is what you want for normal weather avoidance. Now remember those tactical buttons we just talked about, RCT and TGT? Well, if you activate either of those, the system is literally smart enough to automatically force the gain right back to that pushed-in, preset calibrated mode just to ensure maximum accuracy. Pretty cool, right? Over on the right side, we've got the tilt knob. This controls the physical up and down angle of the radar game relative to the horizon, giving you a tilt of plus or minus 15 degrees. And the design here is brilliant. It features an expanded range right between plus 5 and minus 5 degrees, allowing you to make ultra-precise micro-adjustments. But here's the absolute most crucial takeaway. You have to actively manage this knob. If you don't want to blindly fly under or over a developing storm cell, you need to frequently adjust that tilt to scan both above and below your current flight level. And don't worry about guessing the angle. The exact tilt you've selected is clearly displayed digitally in cyan on your MFD. Which brings us nicely to Section 5, Decoding the MFD display. Let's figure out what the screen is actually telling us. Think of your multifunctional display as your weather radar HUD. It is packed with vital data. Up in the top left, you'll see your selected node, like a green WX on or, heaven forbid, a yellow WX fail. The actual radar image is perfectly framed by these white range arcs. You've got an outer heading scale arc that matches whatever range you've selected, and an inner arc marking the exact halfway point. And hey, remember that tilt knob we were just actively managing? Your exact tilt angle digits show up right here in cyan, so you always know exactly where that beam is pointing, down to a precise 0.1 degree resolution. Okay, this is arguably the most vital part of the MFD, decoding the colors of those radar returns. To effortlessly memorize the precipitation threat levels, just use this phrase: big, green, yellow, red monsters. Black means nothing's out there. Green is level 1, your light precipitation. Yellow is level 2, medium stuff. Red is level 3, heavy rain. And the monsters? That is magenta, level 4. That represents the most intense, dangerous precipitation out there. Also, just as a quick aside, notice how in ground map mode, those colors shift just slightly to map terrain reflectivity, making magenta the highest ground return instead. Finally, you always want to be monitoring the screen for important text status alerts. For example, if the stabilization system ever loses its input data, you're going to get a yellow stab fail warning. But here's a great pro tip. If that actually happens in flight, you can physically pull the tilt control knob out to manually disable the stabilization. That will change the alert to a yellow stab off, and you can keep working. You'll also see Gain Man in white as a friendly reminder whenever you've pulled the gain knob for manual control, and a yellow DSPLI off if your radar is running but you've accidentally deselected the image on your control panel.
So, we've covered the whole shebang, right? From the only Smart Weather Geeks test sequence on the main dial, up to those tactical rain compensation and target alert buttons, through scanning, stabilizing, and finally down to fine-tuning your tilt. I want to leave you with a quick thought. As a Q400 pilot, how does building this effortless muscle memory and instantly recognizing those big green, yellow, red monsters translate into safer, more proactive decision-making up there? Because mastering the Primus 660 isn't just about memorizing buttons. It's literally about seeing the invisible and staying one step ahead of the storm. Thanks so much for joining me for this explainer today, and hey, keep those scans sharp.